Okay, and that's why sig figs are going to come in and be important. All right. Also, this is hopefully some stuff that you already have seen before, scientific notation, that kind of stuff, but I got to go over it. We're going to be dealing a lot with big and small numbers in this class. Really big numbers when we're trying to count the number of atoms in something. Really small when we're talking about, let's say, like the mass of an electron or something like that. Incredibly small. Well, how can we deal with this? Well, the more zeros you start adding out longhand, obviously, the more confusing it's going to get, the more likely you're going to be to make a mistake. Same thing with really small numbers. So we need scientific notation. Okay. So this is what I said. It's going to get kind of tricky. Not only that, but if you have a limited calculator, like one of these, you can probably go only up to like 8 or 10 digits. You can't even go to big numbers. You can't even write them out. So you're going to need scientific notation. All right, how do you do it? Well, this number, take a look, right? 1,392,000,000 would get converted into 1.392 times 10 to the 9th meters. Now, some of you say, okay, I know how to do this. Enough with it already. Others, maybe need some practice with this, so I'm going to go over it. Anybody know how far away the Earth is from the sun? Who's leading baseball in homers right now? Oh, okay. Well, you can answer that question, but you don't know the important questions, right? Like, how far away are we from the sun? Why should we care? I don't know. Maybe we'll burn up and die. How long does it take the light to get here from the sun? Anybody know that? If the light suddenly stopped being produced by the sun and shut down, how long would it be before we even knew about it? 8 minutes. It takes the light 8 minutes to travel from the sun to the Earth. So the sun could explode and we wouldn't know it for 8 minutes. Okay? So treat every 8 minutes now differently throughout your life. You never know. This could be right now. We could be standing in the end. We don't know for the next 8 minutes. 93 million miles away. That's how far we are. The sunlight travels 93 million miles in 8 minutes. Some good mileage. Anyways, we'll talk about some more chemistry rock stars as we go along. A little Avogadro. These are the birds and the Jordans. We'll get to them. Anyways, how do we write scientific notation? It's actually pretty easy. The nice part is our decimal system, of course, from here to here is a tenth. This is the hundredths place. This is a thousandths place, et cetera, et cetera. Every time is a factor of 10. So that means every time we move a decimal, we can change the exponent by 1 on this 10. Okay, so that makes it easy. Take this one, for example. How do I write 12,340 in scientific notation? What I'm going to want to do is take the decimal place, find it. Where is that right now? Where would it be right now? After the 0, right? We don't want it there. We're trying to write it in this more simplistic form. So what will we do? We would take that decimal and we would move it to the left until we get it between two numbers that would create a number that's less than 10. Okay? So for example, you would move it between the 1 and the 2. Not between the 2 and the 3, then you have 12.34 something. Okay? Let's move it down farther, less than 10, to 1.2340. So we move it. Now, how many places did we move it? 4, right? We moved it over 4 places. So that would be times 10 to the 4th. Okay, the exponent is how many places we moved it. Now, well, I'll show you the next one. Okay? Now, how do I know whether or not this should be a positive or a negative 4? Because, for example, what if I had a number up here that started with a decimal over here, 0.12340. That's what the next slide is going to show you. Okay? Notice this one. How do I write that one in scientific notation? Again, I find my decimal point where it's at. I put it between two numbers. That makes me a number between 0 and 10. So I take it to, there's where it's at. I take it to here, right? Same as before. The difference is I can't write times 10 to the 4th because times 10 to the 4th, a positive value on my exponent, means that whatever number I started with, it was greater than 1. Okay? And in this case, are you starting with a number greater than 1? No. So you have to write times 10 to the minus 4 on this one. Okay? The number was less than 1. Up there it was less than 1. That's got to be a negative exponent. So a negative exponent references an original number that was less than 1. A positive exponent references a number that was greater than 1. I'm going to, bear with me a second. I've got to cover 2 more slides and then I'll let you go because you need to know this to do the work that you're going to You can always work backwards as well, right? If I wanted you to write this out longhand, how many places would you move the decimal? 6. Which way would you move it? To the left, because you need to create a number that's less than 1, right, because of the negative exponent. Okay, good. So here's a sample problem. If you take the U.S. population in 2004, there it is, express it in scientific notation, stick the decimal between the 2 and the 9, see how many places you had to move it from starting from here, 10 to the 8th. Okay? Now, last thing I want to mention real quick is how to use your calculator. If you do not know how to use your calculator and input these numbers into it, there's no point because you're going to get the wrong answer. So we got to make sure we know how to do this. This is what I'll leave you with. But if say you have this number and you want to do the math, you want to use this as one of your factors in multiplication. Okay? How would you type that into your calculator? What you don't want to hit is the minus sign, then 1.23, then the multiplication side, then the 10, then raise it to that power. It's going to screw you up. Okay? Here's what you're going to do. This spells it out for you, but you're going to input 1.23. It might vary slightly based upon your calculator, but you need to work with this before you do anything else and make sure you can get the same, follow the examples that I give, make sure you can get the same answer. And if you can't, you need to see me or find somebody else to show you how to work this calculator before you do anything else. Type in 1.23. You should have a toggle button that says positive, negative. Okay? Find that and then make it negative because that's what you're starting with up here. So negative 1.23. Now, you're looking for a button. This is what you need, a scientific calculator that has the button that says one of two things. Either EXP, find that, or it may say EE. It depends on what your calculator is. What that means is exponential notation. Okay? Notice what I've done here. I did not type in minus 1.23, multiplication sign, 10. This times 10, this whole unit right here, is replaced by this button. So remember that. Okay? You type in 1.23, you make it negative, and instead of typing in times 10, you hit this button. Then you type in the exponent that would normally follow after the 10. Okay? So in this case, you would make it to the minus 3. So type in 3 and make that 3 negative. Now you've got negative 1.23 times 10 to the minus third. That's what this one says. You'll have to get familiar with your calculator. If you need help, let me know. Okay? We'll start with sig figs next time.